we have almost finished the first module. The second module, most of the portions we have already finished during your our classroom lectures. Now a few portions have been left. Microprocessor timing, the major machine cycles involved, the timing of the processor in terms of instruction cycles and execution cycles. All these things we have completed. Interfacing memory and I/O devices, that is yet to talk about. Instruction cycle, machine cycle and timing diagram. Address space partitioning, that's also we have completed. There are two different schemes in which address can be done. Basically this will be in terms of the addressing of input output devices. These methods are referred to as I/O mapped I/O scheme and memory mapped I/O scheme. In memory mapped I/O scheme there is only one address space. I/O device is mapped as if it's a memory element. First APU address will be given to I/O devices and the remaining address will be given to memory elements. Whereas in I/O mapped I/O scheme, I/O device is treated different from memory elements. They require two different address spaces for the processor, that is achieved at the expenditure of an additional line referred to as I/O bar M bar line, which virtually double the address space of the processor. One specifically for memory elements and another one having the same address specifically for I/O devices. If the content of I/O bar M bar line is high, it indicates that the address sent happens to be the address of an input output device, and if the content of the I/O device, I/O bar M bar line is low, it indicates that the address sent happens to be the address of a memory element. So that's about the address space partitioning. Generation of control signals for memory and I/O device interfacing, memory interfacing, I/O device interfacing, address decoding using 74LS138. These are the things that we have to discuss. So let's see address space interfacing, memory and address and I/O devices. Before that, generation of control signals for memory and I/O devices. We know that a large number of memory as well as a few number of I/O devices are to be incorporated with the microprocessor. Whatever may be the complexity that the processor is employing, there will be a good number of memory elements that are being connected with the microprocessor and a few number of I/O devices also that are being interfaced with the processor. When you make an interface of memory elements and I/O devices, three type of communications are to be sent to the memory elements and I/O devices. First one, for addressing these memory elements and I/O devices, the processor will be sending an address bus. Second one, a data bus for the to and fro communication of data between the microprocessor and memory, or between the microprocessor and I/O device. And yet another set of signals meant for controlling the memory elements as well as I/O devices. How exactly this control can be done, how data communication is possible, how addressing of the memory elements and I/O devices are being done, that is yet to be talked about. We will talk about the control of memory elements and I/O device as well as the addressing of these devices, how this address is being decoded in this module. Data communication, that we will talk about in the upcoming module. You can see that the memory is given a several number of lines coming from the address bus. This indicates that generally memory will not be kept as a single chip. Memory will be divided into several number of chips. Say for example, in 8085 the memory space is 64 kilobyte. This 64 kilobyte of memory will be incorporated with the processor not as a single unit of 64 kilobyte memory. Instead, 8 different units of 8 kilobyte memory will be installed. This has two different advantages. The first advantage is that this gives us the facility of distinguishing certain kind of memory from other kind of memory, which we have already seen. There are two basic type of memories in any microprocessor or in any computer. These are ROM and RAM. ROM will have some different distinguishing feature comparing with the RAM, because generally we will be writing the firmware programs in read-only memories or programmable read-only memories or erasable programmable read-only memories. These are entirely different from the random access memories, because the content of this read-only memory must be unalterable even if you are performing any type or any kind of program using the microprocessor. So sometimes you require 8 kilobyte of ROM, another 8 kilobyte of programmable read-only memory, yet another 8 kilobyte of erasable programmable read-only memory, and the remaining 8 kilobyte unit of memories happens to be the random access memory locations. So generally memory will be an assembly of different types of memory elements. I/O device, as we may expect, will be a few in number. However, their characteristics might be varied. Some of them might have some mechanical characteristics, yet another type of I/O devices might have electrical characteristics, yet another set of I/O devices may have optical characteristics. So they are to be addressed and handled separately. How exactly a control signal meant for a memory element and an I/O device can be generated? In microprocessors employing I/O mapped I/O scheme, we often will have to perform two different operations associated, or the processor will have to perform often two different operations associated with a memory element as well as an I/O device. These are read operation and write operation. So as such, we require 4 different control signals that are to be generated for memory and I/O devices, 2 each for memory elements and 2 for I/O devices. These control signals are signal for memory read operation, signal for memory write operation. These are the only two purposes for which a memory is being handled or is being get in touch with, as long as a microprocessor or a computer or the central processing unit of a computer is concerned. It will have to perform either a read operation or a write operation with a memory element. Also, these are the same as long as I/O devices are concerned. It will have to perform either a read operation or a write operation with the I/O devices. Corresponding to these operations, these 4 basic signals are to be generated as long as the interfacing of a memory element and an I/O device is concerned with the microprocessor. These signals are MEMR bar, indicating active low memory read signal or memory read operation signal, and this kind of an active low signal must be sent to a memory interfaced with the processor whenever the processor is interested in performing a read operation of that memory element. To perform a write operation, the processor will have to send an active low memory write signal, MEMW bar, indicating that this is an active low line. When this line is going low, it indicates that the referred process is being executed. An active low I/O read IOR bar signal is to be sent to an IO device so that it can perform a read operation of an input device. An active low IOWR bar signal is sent by the processor to an output device so that it is capable of sending 1 byte of data to this output device. Generally, in the case of microprocessors employing IO mapped IO scheme, these four basic control signals meant for memory and IO device interfacing are generated using the basic control lines RD bar, WR bar and IO bar M bar of the microprocessor. First of all, MEM-R bar control signal can be generated by an OR operation of IO bar M bar, IO bar M bar line and RD bar line. This is schematically shown here. This is the microprocessor. The three status lines are shown: RD bar, WR bar, IO bar M bar. We already know that if the content of IO bar M bar is high, it indicates that the address presently sent by the processor, or that is being loaded to the program counter, happens to be the address of an IO device. If it is going low, it indicates that the address now happens to be the address of a memory element. By an OR operation of IO bar M bar line and RD bar line, you will be able to generate this signal MEM-R bar. See, this will be going low when both these signals are low. That is when IO bar M bar is low and when RD bar is low. RD bar will be going low when the microprocessor is performing a read operation. IO bar M bar will be going low when the microprocessor is presently addressing a memory element. So when the processor is performing a memory read operation, both these lines will be made low by the microprocessor. The simultaneous Boolean low of these two lines are ORed, are combined to produce a logic low value when both these input lines are low. That will be an active low memory read bar line. This will be going low if and only if both the address is meant for a memory element and when the processor is performing a read operation of this addressed location that happens to be a memory. So by combining these two status lines, we will be capable of producing an active low signal meant for performing a memory read operation of an addressed memory location. ഈ ഒരൊറ്റ സാഹചര്യത്തിൽ മാത്രമേ ഇത് ലോ ആവുള്ളൂ. അഡ്രസ് ചെയ്യപ്പെട്ടത് മെമ്മറീനെ ഓപ്പറേഷൻ നടക്കുന്നത് റീഡ് ഓപ്പറേഷൻ. ഇത് രണ്ടും സൈമൾട്ടേനിയസ് ആയിട്ട് വരുന്ന സമയത്താണ് മെമ്മറി റീഡ് ഓപ്പറേഷൻ നടക്കുന്നത്. അപ്പോൾ ആ ഒരു സമയത്ത് മാത്രം മെമ്മറി റീഡ് എന്നുള്ള സിഗ്നൽ ജനറേറ്റ് ചെയ്യാൻ പറ്റിയാൽ മതി. ഇത് ആണ് നമ്മളെ ആ മെമ്മറി ചിപ്പിലേക്ക് കൊടുക്കുക. The memory chip will be always associated with a chip selection line. This chip selection line will be always active low. അപ്പോൾ ഇത് ഒരു ലോ വാല്യൂ കിട്ടുന്ന സമയത്ത് മാത്രമേ ഈ ചിപ്പ് എനേബിൾഡ് ആവുള്ളൂ. അപ്പം മാത്രമേ ആ ചിപ്പും പ്രോസസ്സറും തമ്മിൽ പ്രാക്ടിക്കൽ കോണ്ടാക്റ്റ് ജനറേറ്റ് ചെയ്യപ്പെടുള്ളൂ. അപ്പോൾ നമ്മൾ MEM-R ബാറിൽ നിന്ന് ഈ ചിപ്പ് സെലക്ട് ലൈനിലേക്ക് ഓഫൺ ദിസ് ഈസ് ഷോൺ ആസ് CS bar indicating that this is an active low line. When a low signal is given to it, then only this will be activated. ഇനി ഒരു IO ഡിവൈസിനെയാണ് അഡ്രസ്സ് ചെയ്തതെങ്കിൽ ഇതിൻ്റെ കണ്ടന്റ് 1 ആയിരിക്കും, ഇത് 0 ആയിരിക്കും. 1ഉം 0യും കൂടെ വന്നാൽ ഔട്ട്പുട്ട് 1 ആണ്. ഔട്ട്പുട്ട് 1 വന്നാൽ ചിപ്പ് എനേബിൾഡ് ആവില്ല. അപ്പം മെമ്മറീനെ ആക്സസ് ചെയ്യേണ്ട സിറ്റുവേഷൻ വരുമ്പോൾ മാത്രമേ ആ ഒരു ആക്സസിങ് നടക്കുന്നുള്ളൂ. നൗ another control signal to the memory element meant for memory write operation that can be obtained by the logical OR operation of IO bar M bar line and WR bar. WR bar will be going low when the processor is performing a write operation. IO bar M bar will be going low when the addressed device is a memory. അപ്പോൾ ഒരു മെമ്മറിനെ റൈറ്റ് ഓപ്പറേഷൻ നടത്തേണ്ടി വരുമ്പോഴാണ് IO bar M ബാറും WR ബാറും ലോ ആവുന്നത്. അത് രണ്ടും കൂടെ ഓവർ ചെയ്തിട്ട് കിട്ടുന്ന സിഗ്നൽ ലോ ആകുന്ന സമയത്താണ് ഈ മെമ്മറീനെ റൈറ്റ് ഓപ്പറേഷന് വേണ്ടിയിട്ട് സെലക്ട് ചെയ്യാനും വേണ്ടി അതിൻ്റെ ചിപ്പ് സെലക്ട് ലൈൻ എനേബിൾ ചെയ്യാൻ